Imagine a world where the very fabric of reality is no longer stable. A world where the laws of physics as we know them are being rewritten by machines so advanced that they defy comprehension. This is not the plot of a science fiction novel. It's the reality we might be living in thanks to the rise of quantum computers. For decades, scientists have envisioned a future where quantum computers unlock the deepest mysteries of the universe. From accelerating artificial intelligence to revolutionizing medicine, cryptography, and even weather prediction, quantum technology has been heralded as the key to solving humanity's biggest challenges. But what if these machines are doing something far more profound than just calculations? What if, by unlocking the secrets of quantum mechanics, we've unintentionally gained access to something we were never meant to control? Unlike classical computers, which process data in a binary format of ones and zeros, quantum computers use qubits, particles that can exist in multiple states at once thanks to a mind-bending principle called superposition. This allows quantum machines to perform calculations that would take the most advanced supercomputers millions of years in just seconds. But this incredible power comes with a price. When Google's Sycamore processor achieved quantum supremacy, solving a problem in 200 seconds that would take the most powerful supercomputer 10,000 years, scientists thought it was an achievement that would reshape computing forever. But recent discoveries suggest that this was more than just a technological milestone. It may have been the first step toward altering the very fabric of space and time. Quantum supremacy is a phrase that has been in the news a lot lately. Several labs worldwide have already claimed to have reached this milestone, at which computers exploiting the wondrous features of the quantum world solve a problem faster than a conventional classical computer feasibly could. Although we aren't quite there yet, a general-purpose universal quantum computer seems closer than ever, a revolutionary development for how we communicate and encrypt data, for virtual reality, artificial intelligence, and much more. These prospects excite me as a theoretical physicist, too. But my colleagues and I are captivated by an even bigger picture. The quantum theory of computation originated as a way to deepen our understanding of quantum theory, our fundamental theory of physical reality. By applying the principles we have learned more broadly, we think we are beginning to see the outline of a radical new way to construct laws of nature. It means abandoning the idea of physics as the science of what's actually happening, and embracing it as the science of what might or might not happen. This science of can and can't could help us tackle some of the big questions that conventional physics has tried and failed to get to grips with. From delivering an exact, unifying theory of thermodynamics and information, to getting around conceptual barriers that stop us merging quantum theory with general relativity, Einstein's theory of gravity. It might go even further and help us to understand how intelligent thought works and kickstart a technological revolution that would make quantum supremacy look modest by comparison. Maybe hard to believe, but paradigm-shifting ideas are often at first dismissed and ridiculed as crazy. Consider the trial of Galileo in 1633 for heresy. Despite Galileo's eloquent defense arguments that the Earth revolves around the sun, he was convicted of heresy and spent the rest of his life, 8 years, under house arrest. The final judgment rendered also banned him from all further TED Talks of his day about the crazy idea, which obviously defies common sense, that the sun is the center of the world, and that it does not move from east to west, and that the earth does move and is not the center of the world. The judgment by the Catholic Church was not reversed until 1992. Quantum computing, like Galileo's heliocentric model, challenges us to see beyond what seems obvious and to embrace ideas that defy conventional understanding. At first, the anomalies were subtle, unexplained glitches in experimental data, small inconsistencies in quantum calculations. These were dismissed as mere hiccups in the early stages of quantum computing. But as quantum computers became more advanced, the distortions became impossible to ignore. physicists running high-level simulations began to notice something unsettling. Future calculations appeared to be influencing past probabilities. In simpler terms, quantum computers may be interacting with time itself, reaching backward to adjust probabilities before a computation is even complete. Imagine flipping a coin. Normally, it lands on heads or tails. But what if, after the coin has already landed, a quantum process altered the past conditions, subtly increasing the probability that the coin was always going to land on heads? Some researchers believe this is already happening, not just in experiments, but in reality itself. The multiverse controversy gained new momentum with Google's claim that its quantum computer, Willow, recently completed a famous benchmark computation, the random circuit sampling (RCS) test, in just 5 minutes. This achievement is staggering because this theoretical task would take the fastest classical supercomputers an estimated 10 septillion years, 10 followed by 24 zeros, to finish. To put that in perspective, the universe itself is approximately 13.8 billion years old, meaning 10 septillion years is about 999,999,998,620 billion times older than the universe. The sheer scale of this comparison defies imagination. How can such an extraordinary feat be possible? The answer lies in the fundamental principles of quantum computing and its use of qubits. Unlike classical bits, which are confined to being either 0 or 1, qubits exist in a superposition state that is a probabilistic blend of both 0 and 1 simultaneously until measured. To put it simply, qubits are neither strictly here nor there, neither fully 0 nor fully 1, but somewhere in between. Google's qubits require superconductivity and can only work in the coldest places in our universe, the artificially constructed refrigerated chambers that hold the qubits. Go inside the Google Quantum AI Lab to learn about how quantum computing works. Video at 3:30 to 4:30 of 6/17. They are measured and made to collapse from a 0 and 1 superstate by use of tuned microwaves. This seemingly impossible property of both a 0 and 1 probable charge is called superposition. Qubits, governed by the principles of quantum mechanics, behave both as particles and waves depending on the conditions. This wave-like nature underpins phenomena like superposition and entanglement. Entangled particles are linked so that the measurement of one instantly determines the state of the other, no matter the distance between them. To me and others, this reliance on human measurements to explain a theory is misplaced. See Measurement Problem, Wikipedia. The instant changes supposedly caused by a measurement also seemingly violate the limitations of time and space and the speed of light. At first, this phenomenon, called quantum entanglement, was met with skepticism, famously dismissed by Albert Einstein as spooky action at a distance. Yet, like Galileo's once ridiculed theories, the fact of quantum entanglement has been repeatedly validated through rigorous experimentation, although no one really knows how it works. Imagine for a moment that quantum computers are already reshaping our world in ways we can't perceive. What if decisions we make today are being subtly influenced by quantum processes in the background? From financial markets to healthcare, quantum computing might be steering the course of events without us even realizing it. The interconnectedness of quantum systems could mean that we're living in a reality subtly adjusted by algorithms far beyond our control. And yet, how many of us even know what's really happening inside these quantum black boxes? It's possible we're already living in a world where reality is being slowly manipulated with consequences we can't fully predict. Quantum computing labs have reported bizarre occurrences that defy conventional physics. Equipment malfunctions with no identifiable cause, particles behaving in ways never before observed, data appearing that shouldn't exist. These anomalies aren't isolated incidents. The more powerful quantum computers become, the more frequently these distortions appear, as if reality itself is struggling to maintain consistency. What if quantum computations are not just processing information, but altering reality? The Mandela effect refers to large groups of people recalling events, facts, or details differently than recorded history suggests. Some attribute this to false memories, but others believe something far more extraordinary is at play. Could these inconsistencies be the result of quantum computers shifting us between parallel realities? And if so, how many times has it already happened? The most alarming revelation is that this process may already be irreversible. Even if we shut down all quantum computers today, the changes they have introduced into reality could remain permanently embedded, or worse, continue unfolding on their own. But instead of hitting the brakes, the world's most powerful governments and tech companies are accelerating their quantum research. The US, China, and the EU are pouring billions into the race for quantum supremacy. Why? Because whoever controls quantum computing controls the future. Leaked reports suggest that some governments have already observed anomalous effects linked to quantum computations. They know something is happening, but instead of stopping, they are doubling down. Some fear that we may have already passed the point of no return. Traditional computers, like the one you're using right now, process information using something called bits. A bit is the smallest unit of data, and it's like a tiny switch that can be either on or off, representing the binary 1 and 0. All the programs, websites, and games you use are built on combinations of these bits flipping back and forth at incredible speeds. Now, enter quantum computers. They use something called qubits, quantum bits. Unlike regular bits, qubits aren't just limited to being on or off. They can actually exist in multiple states at once thanks to a mind-bending principle known as superposition. Imagine a coin spinning in midair. While it's spinning, it's both heads and tails at the same time. That's how a qubit works. This ability to hold multiple possibilities means quantum computers can process vast amounts of information simultaneously, making them exponentially more powerful than classical computers. A calculation that might take a classical computer millions of years could be solved in seconds by a quantum machine. But that's just the beginning. The next bizarre feature of quantum computing is something called entanglement. This is when qubits become linked, so the state of one qubit instantly affects the state of another, even if they're light years apart. It's like having two magic dice. Roll one, and the other instantly knows how to land, no matter the distance between them. Entanglement allows quantum computers to perform complex calculations and solve problems that were once thought unsolvable. These principles, superposition and entanglement, are what give quantum computers their power. But here's the twist. They also bring us into uncharted territory. As we've already seen with the Sycamore processor and Willow chip, these machines are capable of more than just cracking difficult problems. They might be doing something we didn't expect, manipulating the very fabric of reality. If quantum computers are already influencing reality, what happens when they become even more powerful? Some scientists predict that we may start seeing reality glitches, events that contradict recorded history, time anomalies where cause and effect no longer follow logical order, unexplained shifts in historical records as if reality itself is being rewritten. But there's an even darker possibility. An entire civilization erased. What if we're not the first civilization to reach this level of technological advancement? Could ancient advanced societies have discovered quantum mechanics long before us, only to erase themselves through their own experiments? Ancient texts and mythologies describe civilizations that mysteriously vanished, knowledge that seemed far ahead of its time, and sudden disappearances of entire societies. Could it be that every time a civilization reaches this level of quantum power, it accidentally rewrites itself out of existence? And if that's true, how would we even know? As quantum computing accelerates, we must ask ourselves, are we unlocking the deepest secrets of the universe? Or are we blindly dismantling reality itself? If the warnings from physicists are correct, we may already be on the edge of an irreversible transformation. So now the choice is ours. Do we continue forward despite the risks? Or do we stop before we cross a line we can never undo? But perhaps the most unsettling question of all is this: if reality had already been rewritten, how would we even know? Are we on the brink of a quantum revolution or an existential catastrophe? Drop a comment below. Do you believe quantum computing is the key to our future or the greatest danger we've ever faced? And if you want to stay ahead of groundbreaking discoveries like this, make sure to subscribe and turn on notifications, because what's coming next might change everything.